Now let's talk about the area types. You can see I've done a little bit of modification to my topology. I mean, not exactly, I've just added certain things, right? So if you look here, what I've done is I've added probably 100 routes, right? I've just mentioned it as 100 routes in area 10, 50 here, 175 here, 250. I did not obviously wanted to create this route, so I just mentioned it for, for our next set of discussions, right? So now imagine a topology of this sort, right? And you have so many routes, right? Hundreds of routes. So our main objective now is to, right, to reduce the size of the routing table, right? So we have a lot of routes, right? So now let's talk about probably let's concentrate mainly on our area 10, right? If you're talking about the area 10, let me go down here. Let's say area 10, right? What are the total routes, right, in the routing table of my area 10? What do you think? It's going to be, let's classify them. We'll have certain O routes, we'll have OIA routes, right? These are your inter area, and then you will also have your OE2 route, which is your external routes, right? So you'll have 100 O routes, right, because I have defined them, right? Whereas OIA, inter area routes, how many of them will be there? We'll have 175 from this area and 50 from here, so it will be 225 total, right? And OE2 routes, the external routes, you'll have 200 from here and 50 from here, right? You're going to have total of 250 of OE2 routes, right? Great. So when you do a total of this, it basically equals close to 575 routes. Now our whole idea is to reduce this, so we'll start by reducing, probably removing this OE2 routes. So that's where the concept of stub area comes, right? Stub. So what are the characteristics of your stub area? So if you create an area as stub, right, if you go back to this, the ABR will block all the external routes from going into the stub area. Let's say we create this as a stub area, then the ABR, which is R2, will block all the external routes which are coming in, which means the 250, both of these will be gone. Now ABR will also inject a default route into the area to maintain reachability to the external routes, right? But at the end of the day, you want the reachability, so you keep a default route as R2, right? Because even though we have all these 200 plus 50 routes inside this, right, though we might have, at the end of the day, all of them take R2 as the default gateway, they go through R2, right? So the hack here is that you make this area as a stub area, which means you're removing 250, this 250 routes are gone. At the same time, R2 will inject a default route, right, inside the LSA, telling that you want to reach any of these guys, please come through me, right? By doing that, we'll end up reducing the size of the routing table, right? We can see this in action, right? But again, at the end of the day, by doing this, we have blocked our type 4 and type 5 LSAs, right? So let's look into this, how we could do this. So if you look into router 10, right, R10, let's clear this. So you can see if I do show IP route include O, so you'll have some O routes, right? Okay, so I've done it's also showing the OIA as well. All right, so you can also see there are going to be some OIA routes, right? Totally fine. Inter area routes. The next one is the OE2 routes. This is something of interest for us, right? You can see the OE2 routes. There are a lot of them, right? So these are the routes. These are the OE2 routes, external routes, basically R7, R8, and the RIP routes, EAJP routes, they are the ones over here. So if we make our area as area 10 as stub area, right? So how do we do that? We have to do it on all the routers, right? So we cleared this. Let's go inside R2 to start with. Let's go inside R2. Let's go to router Ospf 1, right? And the area 10, we make it stub, right? We need to do the same thing. So you can see, because there's a mismatch of area, it all goes down. So you should do it on both my R4 and R10 as well, because those are also the routers in the same area. So if I do that now, go inside router Ospf 1, right, and we say area 10 and we do stub. Same thing has to be done on my R10. So let's do that. Configure, clear the screen a bit, and we say area 10 stub. Now once we have done this, so earlier if you see, you can see if I scroll up, so you can see there were lot of routes, right? OE2 routes, the external routes were there, right? But now if I run the same command, you will see that you won't find them. There you go, see, you don't find them, they've all disappeared. So we have actually ended up reducing the size of the routing table. We basically ended up removing this. So if you do 575 minus 250, that's actually how much we reduce the routing table. I also told you that this ABR will inject a default route, right? So you can see there will be a default route on here as well. So if I do show IP route on R10, you can see a default route got added, and that was injected by my ABR. So now you will still have connectivity to the outside network, which is your R7, R8 and all of that, right? You will still have connectivity from R10 to all these guys, because the default route is R2 and from here it goes through. But at the same time, you don't have a huge routing table here. All these routes are not explicitly learned, right? So that's what we accomplished using, I can actually show you the connectivity as well, right? So I can probably clear the screen, right? If I do a ping to my outside network, which is say 7.7.7, right? You can see the connectivity is there because it is going through my ABR, but at the same time the routing table got reduced, right? So that was stub. Now there is another area which is kind of like, which complements our stub, called as a totally stubby area, right? The idea of totally stubby area is to further reduce the so if you see now, right, this was the initial, let's say this is regular area, right? This was the regular area, right? By doing stub, what did we do? Let's put that up as well. Let me do that. By doing stub, let's say this is stub. By doing stub, we ended up, so the 100 will still remain, the 225 will still remain, plus one route got added because of the default gateway to it is 226, right? But then we reduced the 250 to 0, didn't we? So the total of this is close to 326. It's 326. So we reduced from 575 to 326. Now we are going ahead and we are still greedy. I mean, we still want to reduce it. So that's where the concept of totally stubby area comes into picture, right? So it's an extension of stub area, which means that there should be a stub area already configured, and then only you can configure your totally stubby area, right? So what is the understanding or the logic behind this? The logic behind this is, if you look at the diagram, if you already have a default route, right, on let's say on R10, if you already have a default route, do we even need the inter area routes, right? Which are the inter area routes? These 226, basically these routes. Do we even need them? Because at the end of the day, even if you want to reach the other area, not only other domain but also to reach the other area, you have to go to R2, and you already have a default route on R2. So do you even need those routes, right? That's the idea behind totally stub area. So characteristic is it's an extension of stub area, right? Which means it will block type 4, type 5, and it will inject the default route like we did in the earlier case. But along with that, it will also block your type 3 now. Type 3 LSAs, right, will be blocked. ABR will block it, right, except for the default route. So how do we configure this? We just configure it only on the ABR, which is my R2, right? In this case, I just need to do it on my R2. So let's look at that. So it's basically R2 is my ABR, right? If I'm not wrong. Yeah, R2 is my ABR. So now if you see here, I can go to, I'm already inside that, so I'll just say area 10, right? Instead of stub, right, it is stub, but along with that I'm also going to say no summary, right? So by doing this, what we have done now is, let me just copy this. So this is totally stubby area, right? Totally stub area. Just go here. So our O routes will still remain, right? 225 is gone, so we don't have the 225 anymore. It's just the default route, the one over here, right? So I can show you that, right? So here, if I do OIA, look here. So we don't have the routes, no more OIA routes. We had the OIA routes earlier, didn't we? We had it here. See, we had the routes, but after doing it as a totally stubby area, the OIA routes also, inter area routes, disappeared, right? So that's why the total now becomes 101. So we reduced it from 575 to 326, and in totally stubby area we reduced it back to 101, right? So those are the three interesting. I mean, this is a regular area type, this is a stub, and this is the totally stub area. Now the interesting thing, moving back to the diagram, let's go back to the diagram. Let's concentrate on our area 20 now. Now we were able to configure this area 10 as a stub because it was kind of like the endpoint, right, of the whole routing domain. You don't have anything after this. But if you look at the area 20, it is slightly different. There is some RIP routes, you know, behind it. There's RIP attached behind it, right? So if we make this area 20 as a stub, right, then what will happen? Your R3 and R6, both of them will block your type 4 and type 5, right? And if R6 is blocking your, you know, type 4, type 5, what happens? Then we lose all the RIP routes, right? These RIP routes will lose. It won't come inside. We'll lose connectivity completely to the RIP section. So hence, in such a scenario, we call this as a, we make an area called as a NSSA, which is a not so stubby area, right? And in this NSSA, how it works is the ASPR tries to fool the system. How does it do? Which is the ASPR R6. It will try to fool the system. What it will do is, it will still block your type 4, type 5, right? But at the same time, it will it will create what you call as a type 7 LSAs, right? So it will convert this RIP routes, this 50 routes, into type 7 LSAs, and you know, that way it is still blocking type 4, type 5. That's totally cool, but at the same time it has converted this type 7, you know, it has created this type 7 routes, right? We will see how they look on the LSA database, but you know, it creates what you call as a type 7 routes. So that's how, you know, type 7 comes into picture. We have talked about type 1, type 2, type 3, right? Type 4 and type 5 also we have talked about earlier. Now we have the type 7, right? Now once these type 7, they can live only inside, you know, a particular area. So it can live only inside area 20. But as soon as these type 7 routes want to leave the area, they are converted back to type 5 by the ABR, right? Because type 7 can live only inside the NSSA area. They can't live outside. So if this is the NSSA area, they can only live here. Also note that there is no default route injected by ABR like we did in the stub area. So we will lose the connectivity to the AHRP though, right? There is no default route like, you know, in this case where, you know, in a stub it injected, right? Here it won't inject. So we'll see how to get around all of that, right? Now let's talking about the NSSA. Let's go back and let's put our stuff here, right? So if I have to do this, let me just hit the tab, probably scroll a bit top, right? Let's call this as a NSSA. What happens in the NSSA? My O routes will still remain the same. We are talking about area 20 now, right? So if you look at area 20, my O routes are just 175. So let's put this as 175. My inter-area routes are going to be, what are my inter-area routes? It's going to be 150. So 150 total. This is going to be 150. And my OE2 routes, which is my external routes, right? My external routes, which is 250, right? Because we are blocking, it's still blocking. NSSA will still block 4 and 5, so this will still be 0, right? But like I said, it is going to introduce a new set of routes called as ON2, basically your type 7 routes, type 7 LSA, and those are basically a 50, right? Like I said, it converts, the ASPR converts this 50 into type 7. So that's how these are going to be learned. The total is going to be around 375, right? So we will see this in action now. If we go to R5, let's go to R5. So we go to R5. Where is R5? This is R5. So on R5, let's look at the external routes. Do we have some external routes? Show IP route and inclusive of, you know, OE2, right? We have some external routes, right? These external routes are basically the EIGRP and the RIP routes, you can see here. Okay, great. Now on R5 we make it as a NSSA. Let's make R5 as the NSSA area, which means I go inside conft router Ospf 1. Great. We call this as area. It's area 20. We make it NSSA. the Ospf will go down because, like I've told you, you need to have the area matching on all of the routers. So we need to do this on R3 and R6 as well, because those are also part of the area. So I need to do that on this guy. So let's do that. Enable clear config router Ospf 1 and put this, sorry, area 20 here. There you go. Do that on R6 as well. Enable clear config here, and on R6 also I'm going to do the same thing. Let's do NSSA. There you go. So all the three routers have changed the area to NSSA, right? Now if I go back to my R5, right, earlier we had some routes, but if you do this now, you'll see that there are no routes, there are no external routes in my NSSA area, which is very much in line with what we discussed, 0, right? But do we have some new routes which got introduced, the ON2 routes? Yes, we have them. So these are basically learned via the type 7 LSA, right? ASPR is trying to fool the system here, right? Because we are telling ASPR, hey, go and block type 4 and type 5. So ASPR is going and doing that, but at the same time it is converting those, it's creating these new LSAs concerning type 7, which is basically the RIP routes, right? So that we don't miss out on them, right? So that's why you get these ON2 routes. Okay, no default route is there, right? As a result of that, you will lose the connectivity, which means if I'm trying to say do a ping to my which one, do a ping to my 7, right, 7.7.7, see, you don't have connectivity, because unlike stub, we are not, ABR is not injecting, it is basically blocking it. It's blocking our type 4 and 5, right? This guy is blocking, but at the same time not injecting anything, right? So if this is your use case, obviously go and use this, use NSSA, right? Now similarly, just like we had totally stubby area to be an extension of your stub, right? Similarly for NSSA, we have two of such extensions. So the first extension is NSSA-Stub. We call this as NSSA-Stub. What happens in NSSA-Stub? It still does whatever NSSA used to do, which is blocking type 4.5, injecting type 7, and then the ABR converting, ABR converting this type 7 to type 5, right? So that is still done. But in addition to that, ABR will also inject a default route, because that was not happening in NSSA, right? And we were losing the connectivity. And for doing this, we have to do this configuration only on ABR. So you go to ABR, which is my R3, right? Let's go to R3, right? And we say area, or basically let's remove this first. Let's remove this, and we say area 20 NSSA. We say default originate, default information originate, right? By doing this, the default route gets injected as a type 7. Right? So now if you see, once we have done this, you can see my R5, on my R5 we will have this default route, right? So do show IP route. If I do, you will see a default route got injected as type 7, which means earlier we did not have connectivity to R7. See, we did not have, but now will we have it? There you go, we have the connectivity. Why? Because the default route got injected. So NSSA-Stub is very similar to NSSA. The only difference is that the R3 will inject a default route, right? So basically, we will still have connectivity to our backbone, or the backbone network like this, right? So you will now be able to reach my R7 because this guy is injecting, right? It's still NSSA. It has the whole concept about type 7 and all of that is still there. Only the difference is that your guy is injecting, R3 is injecting, right? So if I have to go back here and update my database, how it would look is, so let's say this is, let's tap this. So we are talking about NSSA-Stub here, right? The O routes will still be 175, no change there. This is still 150, right? The inter area routes are still 150. external routes are 0, but the only difference is that this, along with this 50, there is one more route, default route, so this gets changed to 376, right? So that was your NSSA-Stub. There is another extension of NSSA called as the NSSA totally stub, right? So what are the characteristics of NSSA totally stub? Let's go back here. So what it does is, basically it does everything as NSSA. It blocks 4.5, it injects type 7, right? And the ABR then converts this type 7 to type 5, right? So those are there. It also, ABR also injects your default route, right? That is also there, which we did earlier in NSSA-Stub, right? ABR will inject those default route, but ABR will also block your type 3 as well, right? That's an extra thing. So that was the characteristic of totally stub also, right? If you see, if you go back here in your totally stub, you can see this OIA routes were going off, right? It was blocking this type 3. So same characteristics is retained here as well, right? We will see how do we do this, or how do we prove this, right? So do this, we will go to my R3, right? Why R3? Where is R3 or ABR, right? So if you want to do this totally stub area, you just need to do the configuration only on my ABR, right? So I'd say I go to my R3 and I say I'm already inside this, so let me remove this command. Instead, what I'll do is area 20, I will say NSSA no summary, right? Or let me actually bring it back to just NSSA, just to show you the difference, right? Let me remove this, let me just make it NSSA to start with, right? It's just NSSA now, old, very old. So before NSSA, this is just NSSA, right? So if I go to my R5 now, I can show you the inter-area routes, right? I can show you the inter-area routes, which means show IP route, include OIA, right? So you can see there are inter-area routes. Now let me go to my R3 and make it totally stubby area. Here you go. Hitting this command will make it NSSA totally stubby area, right? Which means if I go to my R5 now and hit this command, you can see there are no inter-area routes, right? All the inter-area routes are gone. So now what did we do? What did we end up doing here, right? Let me put this also here. So this is totally stub, right? So it's still, it's it's area 20, the OIA routes are still there. The inter-area routes, right, are no more 150, it's just 1, right, because of the default route. Okay, and what about the OE2 routes? They are going to be 0, and the ON2 routes will still be there, right? The ON2 routes will still be there, so it is going to be 50, right? So yeah, we basically ended up, removing this 150 routes, right, over here. It's not 326, right? It's going to be, how much is this? 5 and 6, 326, right? So we reduce the routes here, right? So yeah, so that's basically your NSSA totally stubby area. Okay, you will I can actually show you show IP route. Yeah, so you see your this particular route is still there. This is, I think I did not show this earlier. So this is your inter-area 1 route, right, which I told it will get injected. The ABR will still inject your default route, right? So that's this one. This one corresponds to this. But other than that, you see, we reduced it back to 326, right? So these were your different area types, right? Just to recap, okay, if you have to recap, this was your regular area. Initially we started with the regular area, right? Then we first converted this area to stub area, right? What is the characteristic of the stub area? Why did we do this? Because we wanted to reduce the routing table. So in a stub area, the ABR will block all the external routes. So we remove this 250 and it will inject a default route right into the area to maintain reachability to external routes. So that was just stub. In totally stub area, we ended up removing this inter area routes also, which means we removed this 50 and we removed this 175. Then we went to NSSA. NSSA, we could not make it stub because there was one more routing protocol behind it. If we make this stub, then we would have lost these routes as well. So we made it partially stub, which is the NSSA, not so stub area, right? And in that, what we did was we kind of blocked type 4, type 5. R6 kind of came up with a kind of like a loophole, or kind of where it tried to convert, or it basically created what you call as a type 7 LSA, right, through which it injected these routes inside, and ABR then reconverted type 7 to type 5 back, right. At the same time, ABR also ABR did not inject any default route in NSSA. Now in NSSA stub, what we did was, the only difference is it's same as NSSA, only that it injected R3, or the ABR injected a default route, right. We weren't still happy, we were more greedy, we wanted to remove the inter area routes in NSSA. That's where we ended up creating NSSA totally stub, where we now will block type 4, type 5, ASBR will create type 7, ABR will convert type 7 to type 5, ABR was injecting default route, as well as ABR was blocking your summary or type 3, right. As a result of that, we basically ended up blocking the inter area routes, and we created the most optimized one, right. So if you have a stubby kind of a network, then totally stubby area will be the most optimized, or the one with least routing table. If you have NSSA, then NSSA totally stubby will be like the most optimized or the least routes, right. Great. So that was basically the different types of areas. Thank you. Alright, so we are moving on to the last part of the discussion under Ospf, and we'll be talking about the virtual links now, right. We'll be using a very simple topology here, bunch of routers connected in this fashion with the area 0, 10, 20, 30, right. So alright, so now what I've done is I've actually configured OSPF on each of this router, right, the basic OSPF configuration, right. We could have a look at it. So for example, on R1, or let's look at R7, because that's the first router, right. So if you look at R7, let me clear this, show run section router, right. So this is my OSPF configuration on R7. Okay, you see from the topology, R7, R1 and R2, they are in the same area, right. So if I do show IP OSPF neighbor, right, it should all be good. So R7 is connected to R1. If I do the same thing on R1, let me do this, yeah. So R1 is connected to R2 and R7, so area 0 is all good, right. If I go to R2 and do a show IP route, right, you have all the areas and all the routes properly configured, properly seen on R2. That's good. Moving on to area 10. Now area 10, you see R2 behaves as a ABR, right. It's an area boundary router. So you will still have routes to area 0 even in area 10, right, because you have the ABR over here. So if I look at probably the routes on R4, let's look at the routes on R4. Let me clear this, right, and I can also show you the OSPF config. I've done this already, so to save some time. So you see on R4 I have the OSPF configured, and if I do show IP route, you will have some inter OIA routes, right, which are learned, which are basically concerning the area 0. So you can see you can reach 1, 2, and you can reach 7, right, basically R7 and so on. Okay, that's good. So we are good with area 0, we are good with area 10, and area 10 and area 0 are working together fine. Now comes the interesting piece. We have another area here called area 20, right. I have configured OSPF as usual on all the routers. So ideally, you might think that R5 also should have the the routes for, you know, all these routers over there, but do we have it, right? If we do, let's do that. Let's clear the router. Show IP route. You see here in this routing table, if you see, we really don't have routes to the R1, R2, and basically, you know, we don't have any routes for area 0 and area 10, right? You just have routes to 4, 5, which is basically, you know, in area 20 and area 30, but you don't have you know, routes to other you know, through the routers present in other areas. Now why is this? Why didn't the regular OSPF work in this particular scenario? The reason is because if you see here, the ABR, what is the ABR for this area 20? It is R4. Now R4 is not connected to the backbone area, which is area 0. So one of the condition for ABR is that it needs to have a link in area 0, at least one link in area 0. Now R2 has a link in area 0, so it's working fine, whereas R4, it doesn't have a link, right? It is you know, it is one half of it is connected to area 10, the other half is in area 20, right? We don't have any connection to area 0. So the OSPF you know, works successfully only if you have, you know, only, or this behaves as a ABR only if it is connected to area 0, right? So to overcome this limitation, we use virtual links. It's kind of like a band-aid fix, I would say. A virtual link itself, you know, when we create, is always in area 0, and it will be established between what? Between an ABR which is having an active link in area 0 and the other ABR that wants to be an ABR, in this case R4, right? There are two conditions. One of the condition is that the two routers needs to be connected physically in the same area. So in this case, you see R2 and R4 are physically connected in the same area, which is area 10, right? That area is basically called as a transit area, and the two routers should point to each other's router's ID, right? So now let's configure this. I'll show you how we can configure this, right? So how do we do this virtual link is we go to R2, right? So I think you got the concept that, you know, we are basically going to create a virtual link between R2 and R4 because then they are satisfying both the criteria for creating a virtual link. Okay, so let's clear the screen. Let's go to R2. Let's do router OSPF1, and area, the transit area has to be defined, which is area 10. Virtual link, you say virtual link, and the router ID of the you know, other ABR or the router which wants to be an ABR, in this case R4, right? You did this on you know, R2. Now we need to do the same thing on R4 as well. So let's go to R4, clear the screen, configure router OSPF 1, and area, clearly area 10, virtual link, and you need to define 0.0.2 because that is the router ID, right? So now you can see something came up, right? Let's do show IP OSPF neighbors. So when you did this, you can see that, you know, R4, from the topology, R4 is actually not connected to R2, right? But you can see that R4 has formed a neighborship with R2 via a virtual interface, which is the virtual link, right? This is the virtual link, right? So physically, though it is still connected here, logically, right, this particular router logically was moved from here to over here, right? So now it appears as if R4 is also, you know, having a active link, which is the virtual link in area 0, right? Now because of that, what will happen? If you see now here, if you do a refresh of this show IP route, you can clearly see the difference. Earlier we had routes only 4, 5, 6, 8. We did not have the routes from area 0, area 10. Now you can see we have them. You have the routes from 1, 2, 3, all of these have come in, right? Why did they come in? Because router 4 is now starting to act as a ABR because it has a virtual link, right? At least it has a virtual link in area 0. Got it? Great. Now continuing, you know, similar is the case with this particular router, right? R5, R6. So R5 here wants to be an ABR, but it is currently not able to. So if you see R8 will not have all the routes. If I clear this, enable show IP route, if you do this, you can see I don't have route connection to R1, R2, nothing. We are not getting the routes for area 0, area 10 and all of that. The reason, same reason, because this R5 is not doing the job of an ABR. Now if you want it to do the job of an ABR, we have to configure a virtual link. Now in this case, if I have to go back and remind you the two conditions for creating a virtual link, the two routers need to be connected physically in the same area. So you can't create a virtual link between 2 and 5 because they are not connected in the same area. So you have to create a virtual link between 4 and 5, right? And obviously the other condition is that R4 should have an active link in area 0, but it is having, right? We have just now created the virtual link, so it has a active link in area 0. These both are in the same area, which is the transit area, in this case area 20, right? So these two conditions are more than enough for me to set up a virtual link between 4 and 5, right? So let's go and do that. Let's go to 4. Right, so go to 4, configure router Ospf 1 area 20, right? That's the transit area virtual link, and 0.0.5, right? Gotta do the same thing on R5 as well. So let's clear the screen of it, configure, this is good, and area, what do I do? Area 20 virtual link, and it's 0.0.4 because 4 is the peer in this case. Got it? So now if you if you basically go and refresh this, you will see, probably takes a bit of time. See, now you can see the difference, right? On R8 we are now able to see the routes to 1, 2, 3, 4, 5, 6, 7, 8. You have everything now, right? And that worked because the virtual link got established, and ABR now starts to act as a, sorry, R5 now starts to act as a ABR, right? Yeah, so that's basically what I wanted to show in virtual links, and I think that basically marks the end of the whole series of videos on OSPF. Thanks for watching. Bye guys.